Hello, my dear student. In this video, we'll begin to go ahead and work on with the parsing, parse tree, I mean. So in our parse tree class, we do have the leftmost and the rightmost um, derivation. But in this video, we will begin to focus with the leftmost derivation in a step-by-step manner so that you will really know the so that you can definitely capture out how it will be implemented in a leftmost derivation. And if ever that in your examination will begin to run through with the step by step, so you can also do it like this. Okay. Now, this will be our string that is that will begin to that we will begin to focus with. So this our start state, our head node will be, since we'll begin to go ahead and create an expression tree here. So if you don't know how to work on with expression tree, that is actually part of the data structure also, that there will be an infix notation, postfix notation, and prefix notations. However, here we're just following the derivation in terms of automata theory. Okay. Now, for this one, this is actually an infix notation for data structure, because when we say infix notation, the operands is actually having a operator in between. This is the operator and this is the operands. So our focus right now, class, is to work on with that string with the production rule stated above. Say, for example, here then, after you've inserted E, what can we derive, since for from E going, this is actually a top down parsing. Okay. um for the top down parsing, leftmost, what can we derive from that using this here? So there will be following these principles here, the strings that we do have, I mean. So therefore we can also say E plus T. Okay, so we're able to work on with E plus T. After that, for E, what can we derive for E? In order for us to make this E as, in order for you to work on this as your, what do you call this one? Your goal is to solve that E into ID, okay? That's that will be your goal right now here. So after you work on with cert pertains to this steps. Okay, just give me a second. What will be there, what from node E, what can we achieve? Or if we'll begin to break down that, what expression rule that will begin to follow? So from E there will be T in order for us to achieve F and ID. So therefore it will become um T. Then after T we can derive that by F. Then after deriving that into F, so we can definitely achieve ID. So therefore, ID represent to your A already. Okay. So we're done. So that is ID or A, then plus here. So we're able to solve A and plus. So because once you will begin to implement with parse tricas, you will begin to read that in left manner. The leaf node will begin to read that from left to right, because in our in data structures, if you're trying to get a postfix and prefix, you will begin to perform a specific idea, if it is traversal of in order, pre-order, or post order. For the um for they got this one, I'm so sorry. You will begin to run through with the process in a step-by-step manner. So let me just go ahead and fix this first. Okay. So after, since I wanted you to create this in a step-by-step also in your examination, so that's why I have to run through that here as well. So forget. So E, it will become T. And after T, let me just copy this. Okay. Then after that T will become F. Then after that F will become ID. So this is how you will work on with the step-by-step process. Then you were able to solve that. So after that, you will begin to solve the second left node. Since you were able to solve the node, the right node, you do have t right there, which we can solve right now. So in that t, since we still have exponential form of c, so what can we perform in that one? So it will become, we can derive, in order for us to derive the this one, we have to achieve f first. Okay, so from t, I'm sorry, you have to work on with f. Okay, we're done with f. After that f, so I'm so sorry, let me, okay, oops, so id, right? And after that one, you have to work on here with, in your f, there will be f exponential of f. So therefore, you will be going to insert here f, then exponential, then f. Okay, we're done with inserting those three. So we're able to solve that accordingly. So what will gonna happen? You will be going to simplify first the second f in order for us to achieve the another ID. Okay. Now from F, there will be ID. So we can um, break it down to ID already. So therefore, we're able to solve A plus B and A plus B accordingly. Okay. And afterwards, C. So in your C, then you will be going to create the C times D first in order for us to run through with the process afterwards with the ID. Okay, let's try to copy this first, and then after that, since you are now at F, what you will need to do, you will go back to the E in order for us to achieve this T, and then T times F, then going back to the process. Okay, now it will become E. Then afterwards, we're able to solve the E. What will gonna happen? You will begin to just copy as is here. So it will become, so from your E you have T. So you will be going, you can go back to T. Now after going to T, what can we perform? So in order for us to have the multiplication rule, so therefore you will be going to work on here T. We do have T times, no, 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 T time, I mean, T times F. So therefore, it will become T times F. Okay. Now, we're done with that operation class. What will gonna happen? You have to solve, since you do have already the T, you will perform T, T, will perform that into F so that we can achieve into ID. Okay? Let's try to run through with that process. So let me just copy this for a while. This is really the step-by-step process because, of course, if you will go directly with the process class, you cannot appreciate the step-by-step process that you're trying to use, the leftmost derivation. Because if even that you're trying to use rightmost and leftmost, it will be the same answer or the same representations that you can work on. So that's why it could have been better that you will do it in a step-by-step manner so that we can definitely understand how are you able to achieve the particular idea. Now from T, you will go to F, and after going to F, you will um derive that F into ID already. So let me just bring that here. After deriving this f into id, okay, that's done. So you still have left there, which will be f also, and we can derive that into id, and certainly we are done with the process afterwards. So therefore here, since that the last one will be f, so we can transform that into id, and therefore by reading that from the left to right manner, so we have here id plus id exponential of id times id. So therefore this is true. So since you were able to work on with id plus id, then exponential of id, then times the id. So this is how the process of implementation of this parse tree in a step-by-step manner. I hope, hopefully, class, that you were able to understand and know the process already in a step-by-step manner. If ever that in your examination it will be come as like this, so make sure that you will begin to perform well with the process particularly, because you have to make it really step by step, and you have to take the challenge. Thank you so much, everyone, and goodbye for now. Okay, sorry. And in the next video, I'll begin to run through with the rightmost derivation also.